Alright, so we just put a system of equations in an augmented matrix, performed elementary row operations to put it into triangular form, and you're probably thinking, why are we doing this? This is way more complicated than using the inverse method, the inverse matrix, or even maybe the determinant method with Cramer's rule. But you will see the point shortly. Just stick with me, okay? So what we just did can be done on a calculator very quickly. On a calculator, it's called REF. REF stands for Reduced Echelon Form. Okay, so you find this in the math menu underneath the matrix, on the matrix key. Okay, so you'd hit second matrix, scroll over to math, and you'd scroll down, you see A right there. That's REF, which stands for Reduced Echelon Form. Echelon as a word just means a stair-step pattern. Okay, now here's the thing. If you did this reduced echelon form on a system of equations, you may not get the same thing from your calculator that you got when you did it by hand on a piece of paper. And the reason why is because it may have done some different elementary row operations to still arrive at an equivalent system. So let's just see. Let's see about the one from the previous exercise. Let's see what our calculator would have given us. Okay. So let me put all of this stuff back up here. Here we go. And now let's pull up the calculator and let's type this in and let's see if it gives us the same form, the one that we came up with. Okay. So I'm going to quit out of this. I'm going to go to the matrix menu. I'm going to go over here to edit. And remember, whenever I put this in augmented form, this is now going to be a 3 rows by 4 columns. Okay, so it's a 3 by 4. Okay, and then type in your top row as in the top equation with the 9 at the very, very end.
1, -2, 2, and a 9. Okay. Whoops, I don't think that went in right. 9. Okay, and then the second row is the second equation, -1, 3, 0, -4. Lovely. Last one, a 2, a -5, a 1, and a 10. And hopefully you didn't make any typos, so check it just to be sure. Whoa. That's not, okay, that looks fine. Now let's quit out of this.
In order to do triangular form, remember that's called REF. It is available under the matrix menu. Scroll over to math, and it was A. You can either scroll down to A, it's after the 0, or you can hit alpha A, and it will go straight to it. Inside the parentheses, you've got to put the name of the matrix, which is back under the matrix menu, and that was A. Hit enter. Now look at that system. That system looks a little bit different from the one that we got before, but it at least gave us z is equal to 3 at the very, very bottom. But the middle equation is different and the top equation is different. Doesn't mean that we did our steps wrong. It just means the calculator did different steps to come up with a different but equivalent system to ours. Okay? Okay. So fast forwarding here. Putting in augmented matrix in reduced echelon form is elementary because you're using elementary row operations, right? So let's say this is the augmented matrix that you have with all those letters A through L in it, and we want to try to make that matrix look like the one with all the funky symbols on it. So notice that we have 1s along the main diagonal, 0s for these ones, but the other ones, these weird symbols, are just going to be some numbers. Okay, so this is the direction of the eliminations that we would do. I have to get rid of the X elements and everything but the top row. I have to get rid of the Y element in the bottom row, and then I might have to multiply by something to get 1s in that main diagonal. Okay, so step 1, eliminate the X element in all but the first row. So this is what the E1 is first elimination, second elimination. Okay, step 2, you're going to eliminate the Y element in the last row. So I've eliminated the 2 X's, and then the third elimination is going to be right there, the Y position. Okay, and that just put it into reduced echelon form. assuming that I had ones along the main diagonal. If it wasn't, I might have to multiply by something. Okay. Now then, we could actually keep going to get to, like, keep performing row operations in order to put this in what is called row reduced echelon form. And at the end, on row reduced echelon form, you have your answer. There's no back substitution. It's just, hey, here's your answer. So step 3 is going to be to eliminate the z's in all but the bottom equation. Okay, so look at the pattern here. Here's elimination 4 and elimination 5. Eliminate these two z's. Okay, and then step 4 is to eliminate the y element in the top row. So there's elimination 6. So look at this kind of circular pattern here and how you're supposed to eliminate these. Elimination 1, 2, 3. Elimination 4, 5, and 6. Just kind of going around in a circle. And when you're all done, you have your answer x, y, z. There's the solution, and you're all done. So let's try that on the previous exercise where this is the echelon form, the reduced echelon form. Let's keep doing elementary row operations on it in order to put it into row reduced echelon form. So what is the next element that I need to eliminate? It's going to be this 2 that's right here. I do not want to use the row 1 in order to eliminate it because it would put an x back here. I don't want that. So the only one that I can use is the last row. But it's a 1, it needs to be a negative 2, so we need to add negative 2 times row 3 plus row 2 to replace row 2. Top equation will stay the same, the bottom equation will stay the same. Now just to help my addition out a little bit for my eyeball, I'm going to go ahead and right here multiply the 1 and the 3 by negative 2. Okay, so again the top equation will stay the same, top row will stay the same. Now the new second row is 0 plus 0 is 0, 1 plus 0 is 0, is 1, and then 2 minus 2 is going to give me a 0, and 5 minus 6 gives me a negative 1. Notice that I already have now my y coordinate and my z coordinate. Okay, and that's pretty cool. The next thing that I need to get rid of is this 2. That's the z in the top equation. I cannot use row 2 to do it. I have to use row 3 because it's the only one that has only a z in it. Okay, so it's a 2. The bottom one needs to be a negative 2, so I'm going to have to multiply it by a negative 2 again. Okay, so I'm going to do a negative 2 times row 3 to replace row 1. Since I've already done the multiplication over there on the left-hand side right here, I'm just going to leave it right there. So my new top equation is going to be 1 plus 0 is 1, negative 2 plus 0 is negative 2, 2 plus negative 2 is 0, and then the 9 minus the 6 is a 3. Okay, everything else stayed the same. And then finally, the last elimination is this negative 2. To get rid of that negative 2, the only one that I can eliminate it with is row 2. Because if I try to do it with the bottom one, there's no y in it. And it would reintroduce a z to that position. Okay? But it needs to be the number positive 2 in order to eliminate that number. So we're going to do 2 times row 2 to replace row 1. So let's go back to that other matrix and let's multiply everything in that second row by 2. That's just to help my my addition out a little bit. So 1 plus 0 is 1. Negative 2 plus 2 is 0. 0 plus 0 is 0. And finally 3 minus 2 is 1. What I'm left with on the far right hand side is the solution. Look at the left side. What is that? That's the identity matrix. Basically what this is saying is 1x is equal to 1. The next row is saying 1y is equal to negative 1. And the last row is saying 1z is equal to 3. And there I have my answer. Okay? So, whenever you finish completely row reducing an augmented matrix, you get the identity matrix to replace the coefficient matrix, and what you have on the far right hand side is going to be the solution to the system of equations. which is pretty cool. I know it seems like a lot to do by hand, but you know what? Calculator's going to do this pretty quickly. So that's what we're going to see in the third objective. Okay.